1 2 1 2 1 2 1 2. There we go. We got it. Okay. Okay. You should hear me now. Do you hear me now? I think you can hear me now. I don't know. I think there was a Windows update, and I guess it broke something. But yeah, no. I once you said it, I saw that the microphone wasn't moving. I can see this right here because I can tell you can hear me now. Also, the levels look really good. It should go right into the yellow, so I should be sounding nice and like just at a good level. And then I was looking over, I immediately checked the microphone to see if the microphone was working, which is what that's not the right one. This is the microphone stuff, which you can see the mic setup and everything on this screen right now. And I think we've still got the main voice, everything working good. This is a physical device I have. So that's got that going. And then I'll bring this back over here to the main screen. So you get to see a little behind the scenes and all the things I've created, all the different scenes and everything. And then I need to probably clean this up. If something's running slow, it's probably my fault. It's probably just the billions of things I have created inside of here that create issues. And then, yeah, and why is that? Now it's like smaller full screen. I don't know. Microphone is working good. Yeah, it's pretty fun. I can like change my voice around a little bit, like the bass, the treble, the equalizer. The gate is when, like, if I make a very small noise, you don't hear it. It's like a gate that opens and closes the amount of sound you hear. So if I like breathe in, you don't hear like it's a gate. So sometimes you hear the mic go silent. That's the gate you'll have. And then I thought I equalized my voice more. I'll see how it sounds, but I thought I messed with these values and did the fine tuning on them. And that's the condenser mic. I'll listen to this stream and I'll see how it sounds afterward. Do you notice any change in here? Wait, let me ask you this. What sounds better, one or condenser has on to save those changes? Okay, you can still hear me. Yeah, you can still hear me now. Does this sound better or worse? Like better? 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Is this better or worse? Your thoughts, better or worse? The first one's better. Is this better or worse now? Is this better or worse now? Then we'll get serious, start doing some work. Is this better? You like the first one better? Is this better or worse now? Is this better? Is this like the best so far? And we need to go here to save. It sounds like you're saying this is better now. It's like when you're doing the eye test, you're like, this is the ones, don't you change it on me? We'll save mic profile right here as default to like rename it and stuff. Best mic. Save it to best mic. Okay, so that's the best mic version. I think this might be the better one. I'll go back and I'll listen to this and see what sounds better. But there we go. We got everything saved up, I think. Brian, copy save. Okay, we're good to go. You can actually, this is gonna, I'm not gonna click it. It can show you what it looks like. This is what the device, it's actually, like I said, a physical device. Okay, let's go to the main screen and get some work on. I have to bring the microphone over to each scene now. So let me actually do this. There we go. Now we can hear on this scene. I'm traveling to all my worlds within my worlds, and I think that's all the worlds we mainly use. Mubot. Mubot still talks good. Good. Why are you here, Mubot? Didn't exist in this world right now. Okay. I think that's all the worlds we need. Okay. Hey, Riley, good to see you. We had a mic issue to start, and wait, you can hear me now. Good. Everyone can hear me now on this page. I'm sending announcements, telling people join in. And we're going to do some chapter 4 if people want. Now that we can hear me throughout all the worlds that exist. Sorry about that. We had a little bit of a Windows updated, and I think it broke a connection in Streamlabs OBS. And working on chapter 4. So chapter 4 live. So chapter 4, you want to get it done? Why is it not clicking? Windows, why do you break things? Chapter 4, get it done. Chapter 4 quiz, men's slalom team. Yeah. You want to do the homework? Have you done the homework, Adeline? Have you done the homework first? We can do the quiz. Let's do the quiz here. We'll wait for some people to join in and say, I thought you were doing the homework. I'll say, well, someone wanted the quiz. They're here. Homework's easy, right? Okay, let's do the quiz. Yeah, let's jump on the quiz. Let's do it. Okay. Oh my gosh. It's making me cough. It's too much. The main screen. Oh my gosh. Which ones should we do on here? So much. So much. What are we ever gonna do? Okay, here we are with the quiz. I'm so tiny on the screen, I can barely see it. Okay, so we're going to do the already 14 minutes in. The fonts are even bigger. I can read the timestamp now. That's a plus. Okay, Stat 201. Chapter 4, quiz. Men's slalom team. Okay, let's take a look at that one. It's one of these in here. Where's that slalom time? Slalom times right there. Okay, tell me which ones you want us to work on. We'll grab them. We'll talk about them, and let's get it done. Okay. On this first question here, we're looking at a histogram, which shows us better what? Histograms allow us to it's much easier to see the what with a histogram versus a box plot. We need to know that histograms are univariate displays of quantitative data. See, I almost misspoke. What is easier to see with the histogram? Don't worry about their questions. We'll answer all their questions by looking into this. Easier to see with the histogram. What is easier to see with the histogram? Don't worry about their questions. Focus in on what we're talking about here. What's easier to see with the histogram? Histograms are used to display univariate quantitative data. What's easier to see? With a histogram, it's much easier to see what? Once again, we'll get all their questions right. We'll just do our own questions. What do we see? Mubot's throwing out some points. We already gave out some huge points to Adeline for being here. I would have done a whole office hours and no one would have heard me. The shape, you can figure out the skewness of it, which skewness is part of shape. Great answers right there. Good to see Olivia. Yeah, we're working on it. Just drop a question in the chat. We'll work on it. We do the full homework. People want some quiz questions, so we're doing those right now. You just hop in and ask questions. What's easier to see? The box plot. Now, this is a review of box plots, and I'm highlighting it right here. What's easier to see with the box? I'm giving some big hints. My marker just doesn't work. What's easier to see with the box plot? You got to read my really bad handwriting right now. What is easier to see with the box plot? Doctor handwriting. Easier to see with the box plot. Much easier to see what with the box plot. You can kind of see the separation in the quantiles right over here. This big separation. That's 25% of the data. Biggest marker I've ever seen. And we bring it down. Oh, it is all the way down. 5%. Same amount of data is inside of here too. You see it's a lot more spread out. What's highlighted there in purple? The box plot allows you to much easily see the what? It's much easier to see the 5-number summary. You have 5.5 number summary, which makes up the 0%, the 25%, the 50%, the 75%, 3/4 of the data, and the maximum, which is the 100th percentile. What features of this distribution can you see in both the histogram and the box plot? Well, the distribution is skewed to the right, so we have to choose one of these two. Right to the high, left to the low, whatever way the monster man's tail goes. And so right here, most skiers have between 140 to 160. That looks about right. You see 150, that's not where the central part of the data is. That's 150, over half the skiers are between. That's not right. The middle portion of the data is here, and you can also see it down here, 140 to 160. That's like a bulk of the data. That looks right there. What summary statistics should be chosen? Don't even read their answers. If we're talking about the center of the distribution, there's only two answers, mean or median. So which one would you use, mean or median? This is highly right skewed data. Because the data is skewed to the right, don't even read their answers. We'll find it. But because the data is skewed to the right, should we use mean or median? It's heavily right skewed data, so mean or median. Heavily right skewed data. Heavily right skewed data, mean or median. Very apparent. We've been practicing this a lot. Median, boom. The median would be most appropriate because of the heavy skewness. And then that would be a right answer for me. And great job, Sophia and everyone here. Drop more questions in the chat because we're almost done with this one. What summary statistics should be used in Y for spread of data? Well, if you're using median, what goes with median for spread? Just tell me logically what goes with median for spread. And we'll do another question. Just drop it in the chat. What goes for median for spread? Like, median is the measure of center. The measure of spread for skewed data is what? IQR. So the IQR is going to be best here because of the skewness and the outliers. And we got 100. Was that the one you wanted? Drop another one in the chat. We're just going to do more questions or do the homework. You can just say do the homework. That was one question done. Took us like 4 minutes. We did a full review that box plots show us the 5-number summary. Histograms show us better the shape of a distribution. You can see the skewness by the pull on the quantiles. Notice how the Q3 to max is more spread out, indicating a pull on the high side. Easier to see with the right skew monster man, right to the high, left to the low. But what questions should we do? A lot more questions in the chat. For office hours, your time. It's our time down here. Okay. In a way, box plots are the opposite of histograms. Let's do it. Sugary cereal, that's a favorite. This one, we did this one last office hours or so. Yeah, it's a good one. They kind of show the same things. Like box plots show you 5-number summaries. They give summary statistics. That one catches a lot of people off guard. That one, because there's a trick to it. You can get it wrong. Here we go. In a way, Bella, good to see you there. Cass, good to see you there. Drop some more questions. We only have one question right now. And it's this one right here. We're going to do this one and just drop a question at any time. You join office hours, you can just say, hey, can you do this question? Everyone has different quiz questions, so they're in different orders. In a way, box plots are kind of like histograms, kind of the opposite too sometimes. Let's do it. Explain what we could tell by looking at the box plots where the tallest bars would be. So the tallest bars is where what? Think about answering. The tallest bars is where there's a lot of what? In the histogram. The bar, could you? Yeah, we'll do one next. Charlie, I'm going to copy right here. Charlie's got the next one. The tallest bars are where the majority of the what is. The tallest bars in a histogram, I'm going to highlight it here so you can see it. The tallest bars are where a majority of the what is. The tallest bars are where a majority of the what is. Oh, the background music, sorry. It's ending. You're welcome, Tyler. Here, let me throw some points. It was ending. The majority, I'm basically about to say it. The tallest bars are where the what is. The tallest bars are where the what is. Here's where the tallest bars are. That means there's a lot of what there. What are we here to analyze? We're here to analyze what? Starts with a D. What are we here to analyze? Bad taco truck. That's where a lot of the what is. The tallest bars, a lot of the data. Now notice down here, 25% of the data. Here's the same amount of data here. And look, does it make sense to you that if this was a whole bunch of gold scattered, it'd be the same amount as this gold? Does that make sense? Like this right here, region 1 and region 2 have 25% of the observation, which tells you the top 25% is way more whatted. The top 25% is way more wadded because this is going from Q3, 75th percentile, to the maximum. The top 25% is way more wadded. That's the top 25% right there. The bottom 25% going from Q1 to the min. The top 25% of the observations are way more wadded than this bottom 25%. I'm looking for two words. Something out as I get the hiccups. The top 25% is way more what? Two words in the chat for points. The top 25% is way more what? Two words, something out. Not cut it out. Way more what? The top 25% is way more what than the lowest 25%. That's 25% of the observations. That's the middle 50% right there. May not look like it, might not cut it right. It's way more spread out. Does that make sense? This is way exactly, Olivia said it right when we're saying it's spread out. Exactly. It's way more spread out. Great job, Olivia. How could you tell by the box plot where the tallest bars are? It's going to be these lines right here. Remember, this is the min, this is Q1. So it's going to be the tallest bars. Let's see here. The areas in the box plots where the vertical dividers are closest together. Again, please look right here. Right here is 25% of the data, and that's where the tallest bars are, where the vertical lines representing the quantiles are closest together. So it'd be the tallest bars in the box plot are where the vertical lines, these right here representing the quantiles, are close together. Explain how both the box plot and the histogram can indicate a skew. So skew on a histogram is just the tail of the data. And once again, we got to draw Monster Man. He's going to be mad if we don't draw him. Mr. Monster. Right to the high. So histogram just going to be looking at the tail of the distribution, where on a box plot, it's the separation in the quantiles, which are the lines. So when you have a very tight right here, and then it's pulled out, that indicates a right skew because it's pulled out on the high side. The box plot indicates skew because there are outliers in the right. No, the histogram is going to have outliers in the right. The box plot indicates skew because the min, first quartile, median occur within a small range of data. And look at this right here. What this is saying is that these values right here, we'll get just the box plot. It's saying one in the small range, that from the max, larger range of data, bottom 50%. Makes sense to me why, and in the chat that the bottom 50% is a lot more compact than the top 50%. Both these things contain the same amount of data. It's just that the top portion is more spread out than the bottom. This is 50% down here. This is 50% up here. You can see it better in the histogram, but the separation on the box plot shows you. Are we cutting out? Is anyone else having issues? Is my microphone fine? We had microphone issues to start. Are there issues? Hit Control R on the page to reload. No issues. No issues. I don't know if yes means there's. How is it? Why is it a tech? Why I don't usually. Thank you everyone for saying that. It's better now? What is going on? What is going on? Thank you, everybody. I'll try to answer as many questions as I can. Oh, man. I have no idea what just happened. It might have just been a YouTube glitch. I didn't even see it on my end, though, which is why I'm like, what happened? Usually I can see if there's a weirdness. It alerts me. Identify one feature of the distribution that the histogram shows, but the box plot does not. Histogram shows shape better, and we can see outliers a little bit better. The histogram does not show the median. Boxplot shows the median right there. Histogram shows, no, they both show outliers. The smallest bin, only histograms have bins. So you can't talk about the bin for a box plot. So only the histogram could show you something related to the bin right now. Box plots do not have bins. So the idea of talking about the bin would only be a histogram related idea that the data is contained within this bin. And the box plot does show us the median, which is right there. We should get 100, and we've done it. We got the next question here to help travelers know. Let's do that one. You got it. Oh, the prices one. Ooh, those are tricky, Sophia. And tell me when I do the prices one if it's the one you want me to do, because there's a bunch of those prices ones. So drop. We only have 2 questions on the channel right now. We're dropping some more points for everyone helping out. Hopefully everything's fine with the YouTubes. But we're going to do the National Vital Statistics Report one next. But keep dropping some questions. Drop your question. You can see the right answers like that one people get stuck on. But drop your question. I'll do a full explanation of the question and ask you some additional questions to see if you know how to solve it. Okay, we got the National Vital Statistics. How much are we averaging? We're averaging like 6-7 minutes of questions. Do this one here. Put more in this video to work with. Okay. So the National Vital Statistics Report takes a bunch of data right here on age, sex, race right there. Displays the age of death, sugar, major ingredient. You got it. And with this, we're going to see some histograms right here, allowing us to analyze what's going on with the shape center spread of this data. So every time we do shape center spread, we want to be able to talk about it, and let's see what we see. Okay, both these distributions are very what? Boom, you should see this right away. I want a little bit of, tell me in the chat for some points from Ubot. He's here. He wants to get out some points. Both these distributions are very, very what? What do you see immediately? Right to the high. You know where I'm going with this. We're about to draw him. Back. Left. If you get a question on the test about skewness, it goes. Right to the high, left to the low, whatever way. Talking about the left low. That's the low side of the data. This is a little bit of a bimodal monster man. Monster man's got a little bit of bimodality. Light bimodality right there. Still have a left skew. Great job, everyone in the chat. Jacob and Charlie and Adeline and Olivia. So once again, talking about the shape. And so if it came to center spread of this data, respectively, this comma this, correct center spread to do comparisons here would be this comma this. Like, what is the correct center metric of data to compare? What is the correct spread metric of data to compare between these distributions? Like, I want you to say one comma another, which we're just practicing. Data is left skewed, extremely left skewed, or has extreme outliers. Proper measure of center, proper measure of spread. When you get to the test, it's basically 3 points if you know how to do this. Because of the extreme left skew nature of the data, the proper center, proper spread would be what respectively. Use the extreme left skew of the data, the proper measure of center, the proper measure of spread. What would you say? And we'll look at their questions. They're probably not going to ask anything. Remember, center spread, or shape determines center spread. I won't say anything. I get worried I'm cutting out if no one's saying anything. What do you think? I'll give hints. Only 2 metrics of center we talk about. There's more. There's mid-range. Kind of a center. How is it cutting out? How is it cutting out everyone? Like, what's happening is like, is it skipping? Is it, what is the cutting outness? Like when you say cutting out, what exactly is happening? Thank you for Charlie for saying that. That's probably why people aren't responding. What is happening? You might not even hear me saying this. I might repeat it a few times. Like, how is it cutting out? Is it cutting out? Oh, my voice is cutting out. Do you still see me talking? My voice is cutting out. You still see me talking. So like my mouth, your voice goes in and out. It might be the gate. Can you hear me now? Can you hear me now? Am I cutting out? I think it's the adjustment we made to the mic. It's the gate. Because I still see the mic picking up. Sorry everybody about this. When we started the stream today, there was an issue with the mic and I had to reset it up. Let me go back to dynamic. 1 2 1 2 1 2. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. There we are. Okay, 1 second. 1 2 1 2 1 2 here. Is it good now? Threshold. It's the threshold, I think. It needs to be the threshold. All right, tell me if it cuts. Thank you everyone for telling me all this. Glad we were done during office hours. We had to do some resetting of the mic today, and let me save this profile here again. I mean, I shouldn't have saved it. Okay. Tell me if it's cutting out again. I think it's when I talk quietly, because it's going to be the threshold by which we do the release. And I think we're maybe good now. I think we are. Please tell me. So far, so good. Yeah, please tell me. I think it's the settings on the mic. I'd hate to think the mic is going bad or anything, but I'm seeing the mic going. And so I think it was yeah, so sorry. It seems better now. Thank you, everybody. Once again, the settings, Windows did like an update and we had to redo the mic at the start. If you check out the start of the stream, I'm not taught, you can't hear me. Describe the overall shape of both of these. Both are very left skewed. How do the distributions differ? The distribution for black males has slight more bimodality. It's gonna have a lower center then, because of the pole. It's gonna create like a center here for white males and black males right there. And last but not least, tricky one. Look carefully at the bar definitions. Where do these plots violate the rule of statistical graphics? And the vertical axis does appear to start at 0. It might be hard to tell, but that does start at 0. Please tell me if there's any issues. I think we fixed the microphone-ish. And they do start at 0. The vertical axes do not have the same max, which we want the same vertical axis. So that'd be better to compare apples to apples. The bins do not cover all possible ages. They actually do, because it goes from like under 1 year, 1 to 4. It goes all the way up. Those bins aren't the same size, so the interval width is not constant. Not my favorite question. Not my favorite question. That question was probably messing with the mic right there. Probably why things went haywire was that question. Probably. To help travelers know what to expect. That's towards the middle of the egg questions right here. Oh my gosh, it's like I've done this one. Okay, to help travelers know what to expect. You ready? I need some raise in the chat. Let me throw you some points. Maybe you get points for talking. So this one right here is comparing side-by-side box plots, which is the visualization of two variables, one being a categorical. And is the categorical here X or Y? When you do side-by-side box plots, thank you, W. Bella right there, is the categorical variable X or Y. In a side-by-side box plot, is the categorical variable X or Y. In a side-by-side box plot, is the categorical variable X or Y. The answer is on the screen. It is the X, exactly. It is the X, because X is down here on the bottom of the graphic. This is the X, this is the Y. Box plots are a quantitative Y, side-by-siding them, just puts them side-by-side. And thank you, everyone, for all those answers. So let's take a look. You notice eggs has a lot of variation in the prices, and especially a lot of outliers too. Eggs also has the highest typical price with the highest median. Not a lot to gain from this, but let's see what they ask. In general, which commodity is the most expensive? Generally, eggs is going to cost the most. The median is much higher. And the answer is pretty much eggs. Like, you can just look at medians and say it's eggs. The rest of this, it doesn't matter so much. I hope Rock go through. Did you guys hear the Rock? I hope you did. Is a carton of eggs always more expensive than a bottle of water? Now, this is where I kind of get mad at them, and we're just gonna look at the answers right here, because they get really wacky with these. So is a carton of eggs more expensive than a bottle of water? And if you think about all the egg prices right here and all the water prices, there are bottles of water that are obviously more expensive than eggs. So you could be somewhere in that's like where we're talking about like the country we're in, because we don't really know the pairwise comparisons. So I have clicked, it's not, you really can't tell because you don't know how it pairs up. So, but some water prices are above the minimum prices of eggs, which is a fact. So are there prices of water that are higher than prices of eggs? These, I don't know, I feel like shouldn't be in there because I've clicked them before and gotten it wrong. Is a carton of eggs ever more expensive than a loaf of bread? You see, this says always. And now it's asking, is a carton of eggs ever more expensive? And is the answer yes or no? Don't look at their answers yet. Is a carton of eggs ever more expensive than a price of bread? If you were in a country, would it ever be the case that the eggs were more expensive than bread? Like if you're in a country, would it ever be the case that eggs were more expensive than bread? Is it ever more expensive? Not always, but ever. Let's say ever or always. Let's double check. Is a carton of eggs ever more expensive? What do you think? Is it ever more expensive? I'm getting afraid people are like, you're cutting out. Yes. Well, look right here. Yeah. I mean, this one's all more expensive than all these. So that it could say the maximum price of eggs is above all maximum prices of bread. Might be the answer. There are several prices that are above all the breads. At least one. Is it ever more expensive? Yes. And you can't say bread is always more expensive because water's always more expensive because there's prices of water that are above prices of eggs. So I don't love the way they phrase that. And then there's another version or two of this. Same thing right here. And let's see in general which commodity is the most expensive. We've already said it's eggs. There are prices. These are prices for the same countries. But can you tell whether eggs are more expensive than water in all countries? You can't, because we really can't tell the pairwise comparison. I would go for this. The box plot does not show each commodity. It's hard to say because the overlap. You can't tell. And it's just like you don't know how they pair up. So you don't know if for each country eggs cost more than water. I just don't like the way they phrase these a little bit, because it's like I would just say I don't know if like there's a country with really expensive water that has very cheap eggs. Does that make sense? Because it could be the case. We could just use this graphic here. Like, how do you know for a certain country that this is the country you're talking about's eggs and this is the country's water, or vice versa, this is their water and this is their eggs? So it could be the case that water is more expensive than eggs in this country, and I guess this is us right here right now, and then water somewhere in there. Does that make sense? Like, you don't, I preferably would say I don't know the pairings of all the points. Just the way they phrase it right here, the overlap, there's the possibility that there could be countries with more expensive eggs or more expensive water. It's very hard to tell. Pizza place is kind of similar as the pizza one, yeah. But hopefully people feel better about those traveler ones right there. Now we've got sugar as the main ingredient. That's our last question on the docket right now. What other questions could you? Yeah, the fourth grader one. Thank you. That one gets people a lot. That one has a trick at the end. It's not so much a trick. What was the answer for the eggs in different countries? Olivia, do this because there's two different versions of this. Check back in the video, or we watch it from home. I am showing the answers on the screen because you're here, but feel free to pause the video and then double check your question. That's what I'm saying. That's the wrong one, so you accidentally see that one. But there you go right there. So there, pause the video if needed or rewind a little bit. But there's some answers right there. Could you complete the question of standard deviation on fuel economy ratings? Yeah, tell me the start of the question too, Anna, and I'll grab it right there. If you grab the very start of it, it's how I search for them. I've got two questions right now, the sugar question and fourth graders question, and then give me the start of that fuel economy one, and then I'll be able to find it really easily as I look through the questions, and then we'll do it. We got more than enough time. Okay, I'm grabbing the stuff. There we go. Okay, sugar, it's the main ingredient. Let's go find that. Somewhere around here, I think. Where's sugar? Sugar is the main ingredient. Is it all the way back here? The Boxplots shows fuel economy ratings. You got it. No one wants to do these easy true-false questions, multiple choice. Man, why don't we get to do true-false, multiple choice? Company selling pizzas. Got to talk about sugar. Meaning, I like sugar. There's the crowd crush ones. Those are happy topics. Sugar is the main ingredient. Research initiative. You got it right there, Bella. Thank you. And thank you, everyone, for being here. I'm going to throw you 1,000 points in a second. Really appreciate it. He'll put Bella's question on there, and then we will do the crowd cuts. There's the crowd management strategies. Monitors accents. Okay, we got the, everyone's like, wait, got these right here. I have the fourth grader question, but it's different number on the boys. Yes, we'll take a look at that. Fuel economy ratings, the Boxplots show. Okay, we got a lot of questions. Let's do these. Here we go. Okay, we got the sugar question. I need to mark the time, and the time is 41:48. We should be able to get all these questions done. Let's do it. Okay, so first off, what do we notice right here? We have side-by-side box plots and a histogram. Who can figure out the range of this data which it's going to ask us? And which of these lets us see it? I need someone to tell me the range. Let's just knock these all out. Help me figure out the range of the data. You don't need the histogram. Histogram's going to trick you. So how do we figure out the range? Oh, we deserve that 1,000 points, right? There's 1,000 points, Ella. How do we figure out the range of the data? What do we do? What's the range of the data? How do you get range? Mathematically, how do you get it? Someone's got to help us out in the chat. I forgot how to find the range. Don't worry if you're wrong. What is the range of the data? How do we get it? There's a formula for range. Max minus min. Okay, so what do we need to do? I'm asking because a lot of people get tricked on this. Not a lot, but there are tricks. So how would we find that? What do you think the range is? And then we'll just probably have the question done in like 2 minutes. So what is it though? What is it? What's the answer? It is max minus min. Let me throw you some more points. That is a correct answer. So what is it? I'm asking because people get tricked on this. What is the range though? See if you can get it. This one's your... It is. Great job. You got it. Yep. Just take right here. Max, min, 61. Don't get tricked by looking at this. The bin width, it doesn't mean it starts at 0 and goes to 70. You'll get tricked. There's just data from 60 to 70 in that range. So that's data contained within that range there. So do not get tricked. You did it correctly. Max minus min. So take max minus min right there and apply that number. Very clearly, I hope everyone sees it. It is a bimodal distribution. Don't even click their answers. Know right now that it's bimodal. Just know the answer. What do you think would cause this? Well, you got adult cereal, you got children's cereal, and everyone knows Cookie Crisp, Lucky Charms, Strawberry Schmeagles. So cereals tend to be, you got adult and children's cereals. So sugar content, no. Most cereals, no. Cereals tend to be either of these two. That would make the bimodality of it, that they either have very high or low sugar. Are all children's cereals higher than adult cereals? Well, if you go right here, is the answer yes or no? Are all children's cereals, according to this graphic, higher than adult cereal? Are all children's cereals higher than adult cereals? Yes or no? Just yes or no in the chat. Y or N? Are all children's cereals higher? Yes, they're all higher. So the answer is clearly yes, according to this. Great job, everyone following along. Which group of cereals varies more in their content? Look at the adult cereal has a bigger IQR. The IQR is the range of the middle 50%. So if you go right here, you can see a bigger IQR in the adult cereal. They both have about similar range. The range of the data are virtually equal, but the IQRs are very similar, or the IQRs are different. The ranges are similar, the IQRs are different. The adults have a bigger IQR. Although the ranges appear to be the same, the adults could more variability for adults. There we go. Let's got it. I said we'd just take a minute or two and we did it. A class of 4th graders. Let's go do that question. 45, 4-3. That one's towards the end here. Drop more questions if you have them. We have time for just a few more, but we're going to do this class of 4th graders question. And what are we given right here? We are given the 5-number summary. The 5-number summary. Give me a thing from the 5-number summary, and I'll start writing it in here. Give me a thing from the 5-number summary. And if you forgot how to do the 5-number summary, draw yourself 4 quarters. Go quarter, 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 and then put lines between them. And so you can see the lines right here. The lines being there, 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 there. Oh, where did they put the extra? Oh, because I see what they did. The quarters are going to be there, 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 and there. So can you do describe? Yeah, we'll try to do that one, Bella. You got it. So what's something from the 5-number summary? What is something from the 5-number summary? I need a measurement from the 5-number summary. Give me a measurement from the 5-number summary. Some sort of measurement. The minimum. The minimum's the lowest. And a great thing to do when you're trying to remember it is to put 25 between all these, and then to think that 25% of the data is between these values. So you have the min, the max. I'm looking max right there. The median, the Q3, and the Q1. And how this relates is this is the min, this is the max, this is the median, this is the Q1, this is the Q3. And there's the 5-number summary. Good practice. We can also find out things like the IQR by going from Q3 to Q1 and figuring out their distance is the IQR. We can also figure out the range by going to min to max, which is just literally what a range is. Min to max is the range, and you could do it for boys and for girls. So let's take a look at the answers or the questions and see what we got. Which group had the highest score? Very clearly, it's going to be the girls with a highest score of 5.8. Which group had the greatest range? We just subtract max minus min. I think it's the girls again. Yeah, because they have a lower min. If you have a lower min and a higher max, then you obviously have the greatest range. Subtract the numbers, get 3.5. If you're wondering what we're doing, we're just doing 5.8 minus 2.3, 3.5. Please correct me if I'm wrong. Which group has the greatest interquartile range? Girls have an interquartile range of 1.2. That's just a difference of 4.4 to 5.6. And boys have 1.4, 3.9 to 5.3. So it's going to be the boys right here with a range there. Please slow me down if you're confused, but we're just figuring out the distance. And we showed it here visually. The IQR is in yellow and the range is in blue. So know those quantities and know what the 5-number summary is. Which group generally did better? Well, we could look at the medians right here because that's what box plots or 5-number summaries analyze. The girls generally did better because their median is higher. Now, here's the one people get stuck on. Okay, so what is the answer to this? Now, I'm going to ask you this. Do you know what the answer is? It says 4.5 is for the boys and 4.8 is for the girls. I'm going to tell you the quick solve for this. 4.5 for the boys, and it says round to 1 decimal. So what should I enter in? You're going to say, what? Does anyone know what I should enter in? I'll give you points for guessing, but I got the version where people get it wrong. So does anyone know the answer? To 1 decimal, what should I put in? And they say, no, it rounds to this. Take a guess, see if you can figure it out. It says of the 13 boys, and that's a huge hint, the average was 4.5. Of the 12 girls, the average was 4.8. So what's the average? Does anyone know? To 1 decimal, what would it be? Take a guess, and we'll give points in the chat. This is the part everyone gets wrong. And then they're like, Brian, I was 1 decimal off. And I said, oh, but you got to watch out. It's a very important thing to note. And they were just mean on this one. It's a little mean. Anna, let's start Anna 1,000 points. Anna, you're right. Anna is correct. It is 4.6, rounded to 1 decimal. And so the issue is there's more boys than girls. So because there's more boys than girls, when you do the math on this, you would have to say of the 25 students, which is 13 plus 12, there's 25 students, 13 boys, 12 girls. You'd have to say the 13 boys had an average of 4.6 plus the 12 girls. Oh, wait, 4.5, right? Sorry, 4.5 average. And then the 12 girls had an average of 4.8. And if you solve this out, you will get a number that rounds down to 4.6, just barely. You skim over the other 4th grader question as well. Is there another one? Let me know. Does it start the same? I thought this was the key one. What's the other one? Oh, really? I did this way wrong. 13 times 4.5. There's that. Let me close this. 12 times 4.8 plus divided by 25. I think I divided around. I mean, it's so close. Jacob, how's the other one go? 4.644. And that rounds down to 4.6. If there are more girls than boys, then if the girls have the higher average, it will round up. I had 14 boys and 10 girls. In this one, I have, So if you have, and if the boys scored lower, it's going to pull towards the boys. Do you see how to do the math right here? This is how to find out the math answer. So you literally have the amount of boys, boy average, the average, and then this is the girls and girl average. And then you have here total students. Yeah, so that's what you have to enter in to do it mathematically, or you could figure it out theoretically. It said it was on attempt 5 of 7. There's usually 5 attempts, Jackson. I could take a look at that afterwards. Yeah, give me a moment, Jackson. Or email me, Jackson, and I'll figure out what's going on with that. Thank you, Jackson, for starting early. Could you crowd management? Yeah, here, we'll move that one up on the list. 2 people have asked, or 1 person asked twice. Either which way, let's move it up on the list because we've got a little bit of time. Let's do the crowd management one. It's going to show us 2 histograms, I think. We'll see right here. A large venue is a large venue, small venue. I don't know. Let's find out. Let's look what the question says. Let's go do crowd management strategies. Thank you everyone for being here. This is amazing office hours. We're getting so much done. So much room for activities here at office hours. It's like we got a stepbrother. Gosh. Frozen pizzas. No, don't crash out. No, you're starting early. Just let me know what's going on. Let's check out this one here. We're not going to crash out. We're going to start cooking right here. No crash out, only cooking. Okay, we got a histogram and a box plot next to each other side by side. Pretty easy, clear to see that there's some high outliers over here. And we can kind of see what's going on with this. We have the vast majority of people, and this is a rather sad thing, people who have experienced crowd crush at a concert. Vast majority of people in the 17 through 22 range, which is the IQR, the middle 50%. You got an old person over here in their 40s like me, 46. Sure, my best friend. It's me, my best friend Plank. And another outlier. It's an outlier over there. And then we do have the Q3 over here. We're basically marking spots within the box plot, and there's the min, and they are the max. We can see the vast majority of data within here and a slight second small bimodal peak. And we have outliers over here. And how could we forget Mr. Monster Man with his right skew nature? You can't forget Monster Man. He'll be really sad if you don't draw him. He was sitting in the background here like this, and like, why are you not talking to me? Right to the high, left to the low, whatever way the Monster Man's tail goes. Sorry, Monster Man. And so what we would say about this is it's very right skewed. Most victims were between the 16 to 24 age range. Notice in here, we see that big modal area, modal meaning concentration of data area, 16 to 24 range. Ooh, yeah, that's the vast majority. It's not 24 to 30. That's ridiculous. So we're definitely looking in that range for the vast majority of data. And there are the high outliers we mentioned just a moment ago, 36 and 48. I said 47, but, or 40, I don't know. I said 40 something. What feature of the distribution can be seen in the histogram that can't be seen in the box plot? Histograms are better at showing shape. So something shape related, the slight increase, which is easier to see, that second bimodal area, which we didn't point out over there in the box plot, because histograms are way better at showing shape. What summary statistics would we choose and why? Scream it with me. This is right skew. Please say it. I know I've been burning through this question, but say it. You know it. It's right skew. So obviously what? Obviously what? You look at data, you're like, that's right skew. So what measure of center should we use? And then spread, respectively. We're just going to destroy these last two questions. Like, center and spread? Come on, it's right skewed. Median, because it's skewed to the right with outliers. Median, because slight skew. That's pretty darn skewed. And then IQR would be because it's also skewed, which is a measure of spread. Remember, IQR is spread and standard deviations are a measure of spread because of skew. And we're doing it. We're cooking right here. The research, innovation. Thank you, everyone, for answering that right there. It really comes down to repetition. You'd be surprised how easy it is to get something wrong. That if you just repeat it multiple times, you'll remember it and be like, oh, if it's skewed, median and IQR respective for center and spread, as in median, center, spread, IQR. If it's more normally distributed, mean and standard deviation for center and spread respectively. Okay, here's a box plot. Trying to grab the next one. The next question. Where are they? So research, we found it. Here we are. We've got 55. We're going to try to do a few more. Here we go. That last question took 3 minutes. Let's do this one. We got some statistics right here about airlines. And my golly, both of these are skewed to the what? Which way is this Monster Man going? I'm going to start drawing a little bit on this. I want you to talk to me about the skew. So when you get to the test, it's the freest points you've ever seen. And Bella knows right there, they are left skewed. Got a left skewed Monster Man right here. Left skewed, even more left skewed Monster Man over here. A little hard to tell, but centers of these distributions, which are best described by the medians, are going to be about here-ish, maybe, and here-ish, maybe. Which means the April-August has a higher median and a smaller spread. So we would say that the spread is smaller and the center is higher. So does that make sense to everybody? This is a tighter distribution. Even if you talk about middle 50%, it looks to be tighter around the median. So this has a smaller spread and higher median. What do they want us to look at right here? Both distributions are definitely skewed to the left, so we've narrowed it down. Which ones have more variety? The ones that vary more is April, August, which is the summer months. September through March, that's winter. So summer has more variety. Summer varies more. I think that's right. Really? Really? I don't know months. That's because I don't know months. Fall and winter load factors appear to vary more. April through August. It's winter? 1,000 points. I don't like this question. I don't understand months of the year. They should have just put April through August. September to... Oh. Oh, it is, isn't it? I haven't had lunch. Oh, fall to winter is very more, exactly. Kai right there, 1,000 points again. I appreciate that. I'll learn months of the year. I gotta take a course at UT here. It's very possible to misclick. Get some more attempts on it. It can happen right there. Very easy to misclick, misread a question, or don't know your months of the year. Happens to the best of us. That's why we got a bunch of attempts. So practice up. Best, it can happen to all of us. Miss a question. I don't know how to look at those and see which one's what. Okay, let's go here. Throw in another question. 58, fall to 3. Gotta take that course at UT months of the year. The Boxplots show the fuel economy rating. Oh, I think it's right here, right? Ooh. What just jumps out to you right here? A big old what? What is way out there, which is an electric car? Study reports load factors. I think we did that one earlier. Did we not? We might have. Tyler, we might have. Yeah, or I'll try to find it. Might have just enough time. I've got it marked. What jumps out to you right here is right above my head. Or now it's above my head. What jumps out to you? And I think we fixed the clipping in and out, right? I think we fixed that. I think it was the gate, which is, I'm glad I found it. What jumps out to you right here? Anything jump out to you? Anything? Outlier. What is outlier going to impact the most? What do you think outlier is going to impact the most? Which this follows this. If you look, this is being pulled over here away from this quantity. Is there? The mean follows the skew. So outliers dramatically impact the mean, not the median. So how will removing the electric car affect the standard deviation? So standard deviation is how things deviate from the mean. So if we remove something far away, would things deviate less from the mean or more? Standard deviation is a metric of spread from the mean. Mathematically speaking, so would there, because it's y sub I minus the mean, the difference from an observation and its mean squared over n minus 1 square rooted is standard deviation. So the question is, how far away are the observations from the mean? That's the main part of it, the part doing the work in the equation. So if we remove an outlier, things would have more variation from the mean or less variation from the mean. If you remove something far away, there'd be less variation from the mean or more variation from the mean, which is standard deviation, is variation from the mean. So would things deviate less from the mean? There'd be less variation from the mean because the variation is spread of data. So it'd be less spread out. Don't worry, Ryan, we're throwing Ryan 1,000 points right there. Good answers. Don't worry, we're here to practice. So standard deviation would be much smaller because things would vary less from the mean. And it talks about since the standard deviation is calculated by summing the squared differences. So yeah, well, they literally say what I say right there, the squared differences. So they're showing you the math behind it or talking about it. How much will it affect the IQR? Why do we have IQR? Because IQR is not impacted by outliers. So the outlier is not going to do anything to it, really.
It doesn't matter.
Pretty much got it right there. Cool deal. That's got that one. We are just rocking and rolling. We got just barely a little bit more time. I think I got till 4:05. Study reports load factors. Let's find that. Study reports load factors. Study reports. Yeah, everyone wants study. Let's do that one next. Study reports load factors. Is that the flight one? A study report. Thank you for all the nice, pretty capitalization right there. We have done, I got to make sure to save this. There's been like one off hours where I didn't save the notes and then I felt bad. We are jumping the list on this one. Commercial airlines. It's like the months, right? It's kind of a so-so question. There's questions I love. This one's great. This is an A+ question. Like, this one really goes over the idea that the standard deviation is impacted by outliers and the IQR is not. So yeah, it could have you calculate and stuff too, but I don't know. We do that in the background. We did this one last office hours. A good tricky one, but we did last office hours. Here we go. Okay. So you got the overall data down. Oh, I got a part. Let me put the timestamp. That way people come back. 102, 52, 62. That's not going to work. 52. Okay. So you can see the monthly data, or the yearly rather, and this stands for 2002 all the way up to 2019. The yearly data is not going to have as much variation as all the data. This is every bit of all the data, and this is yearly up here, as it even says yearly down below. So that's the yearly data, and points that are not weird in the main box plot are seen as weird in the overall, or are seen as weird in the monthly data, because that is yearly. This point right here is weird for that year, but down here it would be in the box plot as something that is more commonplace towards the center of the data. So it really depends on how you plot data in the context. Are we looking at over all periods of time, which is a lot of variation to take into account. And now you see there are some, especially the first few years, some weirdness, some unusual points. But in those years, they weren't unusual for that year, hence the context. So an outlier is always context dependent. Is someone an outlier if they are 4 feet tall? No. What if they're in like, well, then they might be an outlier if they're in like second grade. They might be really tall. I don't know what height people are supposed to be at what age. Not supposed to be. I'm too tall, they say. My back says so. But it's all context dependent. So when is something an outlier? When it doesn't follow the trend in the data, which is usually seen as like mean or median to compare data. So context dependent, that is an outlier. Context dependent down here, it wouldn't be an outlier. Context dependent, these are not outliers. Context dependent, it is outliers down there. It's kind of what they're getting at by showing you how you break up the data. Oh, outliers are context dependent. What? I've done the question before. Outliers are context dependent. Data values that seem ordinary when placed against the entire data set may stand out when compared against data each year. That sounds about right. Data sets that seem ordinary when placed against 1 year's data may stand out when compared against the entire data set. Data values that seem ordinary when placed against 1 year's data may stand out when compared against... These all sound the same. Data values that seem ordinary when placed against the entire data set. That's what we saw, right? Data sets that may seem ordinary when placed against 1 year's data. Kind of both these are answers. Data values that seem ordinary when placed against 1 year data may sound... No, this one's wrong. Okay, so we're really between these two. Data values that may seem ordinary. Okay, so actually the majority of the outliers are coming down here. This is where the outliers. So they seem ordinary in the yearly. That's the trick to this. You don't really have the outliers here. There's one. They shouldn't have put that one in. That would have made the answer obvious. But the outliers are appearing down here. So data that may seem ordinary when looked at within the years may not be ordinary within the entire data set. Data values that seem ordinary when placed against 1 year's data. No. Data sets that may seem ordinary when placed against the entire set. Data sets that may seem ordinary when placed against 1 year's data may stand out when compared to the entire data set. I'm 99% certain. Got it. And because they're ordinary within this, data that may seem ordinary within the years, there's only one outlier, may stand out in the entire data set. And it is very much looking at exactly what they've written. And literally, I said outliers are context dependent. Summary statistics. Yeah, this might be our last one, Bella. Thank you so much. The histogram of summary statistics for public parks. We have done this one, but Bella, let's do it again. We did it last office hours, and it's a good one to kind of end on. I'm going to make sure we get the notes on this. So we might do it a little quickly here, and I need your help. So everyone listen in and help me out with this question. I should grab a protein bar between class, but goddamn, I got this. My class. Okay, so this one right here has a lot of computations to do. So we're going to have to do a little bit of math. I like math here, though. Here it is. Let me take the timestamp. This will be our last question. We do have a lot in this video right now, though. We've really done a lot of work. 107, 13, 12. Well, that's fine. Okay. So we need the information over here to draw what? The 5-number summary allows us to draw what? What does the 5-number summary allow us to draw? Help me out with the answers to what I ask. You got this. Let's throw some points. The 5-number summary allows us to draw what? What is the what do you draw with the 5-number summary? You go down here, you mark this, and then you draw what with the 5-number summary? What do you draw with the 5-number summary? What does the 5-number summary draw for us? What does the 5-number Boxplot? Kai, got it. What is the length of the IQR? What is the length of the IQR? Tell me the length of the IQR. What is the length of the IQR? You have to mathematically calculate it up there. What is the length of the IQR? Oh, I gotta go a little quick. Save my notes. How big is the IQR? He's got to tell me the difference in the numbers. Q1, Q3 minus Q1. And so what is it though? What is it though? That is true. Fact of the world right there. Kai got it. So what is that? What is Q3 minus Q1? You gotta do it. What is it? Because when we figure out where the fence is at, the fence is going to be Q3 plus 1.5 IQR. Whatever that was. 50, you got it, Kai. Great job. And Q1 minus 1.5 IQR. That's where the fences are at, that 1.5 number. Very important number sometime on the quiz. And so what we do is we plug in right here, and we go to Q3, which is 78, and we go plus 1.5 IQRs, which is 50 times 1.5. I am blocking that. And it's 50. Great job, Kaya. And so that means this is going to be at exactly 153, which is somewhere in here, which means we don't know if those are outliers or not. When drawing this, it could look something like this. We don't know exactly where that goes to, and then there are going to be outliers right there. And then we got this, and the median is at 43 right in here. So we've got a decent drawing of what this should look like. It might have 3 outliers. I think it does. Let's go take a look at the possibilities of this. Because the distribution is very skewed to the right, the median should be used, and the center should be IQR. Once again, skewed. There's 3 to 5 outliers because I don't know if these 2 points, there's 2 data points in there. That's the height of the bin. I don't know if they're outliers or not, and they'd be measured by the amount of IQRs above Q3 or below Q1, respectively. Here we are with create the box plot. Now they're showing us that, once again, we have to have this extreme high outlier. So the only possible answers are these 2 right here. Now, when you look at this, we have to figure out where is Q1. Q1's at 28. Since Q1 is at 28, this one is way too low. That is not where 28 would be. That is not a third the way up that scale. So remember, the bottom of the box is where Q1 is at. So because of the high outlier, which represents the highest point in the data set, which is 275, that's where 275 is. And then the bottom of the box right there looks to be about where we would expect 28 to be, which is a little more than the third up this scale from 0 to 75. So the distribution of the number of campsites is very, it's unimodal. Don't be charged. It's unimodal. That's one mode, and very skewed to the right. The center of the distribution is going to be where the median is at, which the median is at 43.5, which is rounded to 44. The distribution of campsites has it's very spread out. And these parks that are very spread out right here have in excess of 153, whereas where we calculate the upper fence. So I had to do a little quick right there. We go over it a little bit slower in other office hours, but I have to be teaching in 7 minutes. So everyone, excellent work. Until then, bye for now. Bye. Next time.